Alright, so today we're going to be solving linear equations by substitution. Remember, when we're solving linear equations, there are two straight lines intersecting, and we want to know that intersection point, the x and the y coordinate. So in doing so, we've done this before graphically, but there are methods where we don't have to use a graph, such as the substitution method. So when we're doing the substitution method, it'll be an algebraic way of actually finding the same x and y coordinate we would find as if we would have been graphing it. So let's look at the first example. Example 1a. The equations will be y equals 2x minus 4 and 7x minus 2y equals 5. So these two equations will form a straight line and they will intersect. However, I'm not going to graph them. I'm going to do this algebraically. This is called the substitution method, but I call it the nickname method because when you substitute something for something else, it's pretty much like a nickname, right? You have a name for something that represents the same thing as another name. So first step is to find an isolated variable. I found y, which is isolated here. And I'd like to see this as y having a nickname. And I will box in what I call the nickname. The nickname because 2x minus 4 is the same thing as y. So instead of saying, hey y, what's up? I can say, hey 2x minus 4, what's up? Just like people say, hey Blanca, what's up? Hey Miss Flores, what's up? I'm still the same person regardless of whatever name you give me. So they're telling you here that these are the same. So I'm going to use that term as I am saying this second equation. So it would say 7x minus 2, but I'm not going to call it y this time. I want to use y's nickname. 2x minus 4 equals 5. And when I do that, it's going to look a little more complex, but we can also simplify that, okay? Now, the reason we do this, if I were to ask you to solve this equation as we usually would, you would draw the line and then you decide on getting your variable by itself. But you can't do that because you have two different variables. And it'd be like, wait a minute, make up your mind. Which one am I going to solve for? There's two of them. So it's not even possible, okay? So we're going to do this substitution trick and you'll see how that fixes that problem. So it's going to become 7x minus 2. Again, I'm not going to call y by y. I'm going to call it by its nickname, 2x minus 4 equals 5. Right? So y's nickname is 2x minus 4. Okay? I did not change the equation. I am actually just substituting the nickname for y in there. Okay? So now, notice I don't have a y in my equation anymore. It's all x's. So now I can focus on finding x. So in doing so, we're going to distribute. So 2 times negative 2 times 2 is negative 4x. And negative 2 times negative 4 is positive 8. 7x is still there. And 5 is still there. And now I'm still solving, but not yet. I'm in the process of trying to make this look simpler. And in trying to make this look simpler, I can put together some like terms. This one and this one. And when you put these together, we get 3x plus 8 equals 5. And now I'm trying to solve it now. Inverse operation of addition is subtraction. Subtract 8. And then now I'm going to get 0 here, negative 3 here. I'm going to bring down this 3x. Almost there. To eliminate that 3 that's with the x, the inverse operation of multiplying by 3 is dividing by 3. 3 divided by 3 is invisible 1. And negative 3 over 3 is negative 1. So now, I did say we're going to have a point as our solution. And we just found our x coordinate, negative 1. All right, now I have to find my y. So looking at the original problem we were given, they tell us right here what y equals. If I want to know this y, it's right here. So you most likely will always go back to the nickname. Y equals 2x minus 4. So that's what I'm going to use. I used a bubble for my x because I do know what my x is and I'm going to be plugging it in. And we just did the math and we found that x was negative 1. So now my solution is going to be 2 times negative 1 is negative 2 minus 4, that's negative 6. Y equals negative 6. So this is my solution, the point where those two lines intersect. All right, so let's do one more. Y equals 2x plus 3. And y equals 5x. Now notice this one has two isolated variables. So in this case, it's like saying Miss Flores equals Blanca and Miss Flores equals Estella, my middle name. Some people call me Blanca, some people call me Estella. So if I say Miss Flores is Blanca and Miss Flores is Estella, I can also say Blanca is Estella. We're the same. So these two are equal to each other. So you can do it that way, or you can do the process of identifying a nickname. In this case, it doesn't matter which one. So I'm going to call this one the nickname. So 2x plus 3 is the same as y. So now in this equation, I'm not going to use y. I'm going to use 2x plus 3, the nickname for y, equals 5x. Okay, so I could have put parentheses, but there's nothing to multiply. Now we're going to solve for x. So again, let me go back. Using this nickname in this equation is the same as saying, hey, wait a minute, if they're both equal to y, then they're both equal to each other. And that's what I wrote here, equal to each other. So you get the same thing, either plugging in the nickname or recognizing that they're both equal to the same thing, so make them equal to each other, right? So let's go ahead and solve this for x now. I'm going to put my x's on this side and my numbers on this side, constants. This was the story I told a while back about all the numbers on one side, x's live on the other. So the only out of 1, 2, 3 terms, the one that's in the wrong place is this 2x. It should be over here. So the opposite of a positive 2x is, oh, that's not dark, is a negative 2x. What you do to one side, you do to the other. That's gone. So now I have just 3 over here and a 3x over here. I'm trying to get x by itself, so we're getting rid of that 3. Opposite of multiplying is dividing. That's invisible 1x. And then here we get 1. So x is 1. And now I need to find my y. And notice up here we have 2 to choose from. The bottom one is simpler, so we'll use that one. Y equals 5x. Okay, we just found x and we were trying to find y. So looking on your paper, do you see anything that says y equals? Right here. So I'm going to use it to find y. And I'm going to plug in that 1 that I got. And 1 times 5 means that y equals 5. And that's my solution where these two lines intersect. All right. So now let's just narrow this down in what kind of steps did we do. So the first thing, if we just want to narrow down what the process was. First thing we did was we located an isolated variable. Now, the reason why we located an isolated variable, right, because you wanted to find the nickname. So I'll just put on here nickname. And get your nickname. Okay. And then second thing we did was we used the nickname in the other equation. I'll put it in quotations. Okay, so once we found our isolated variable, we identified the nickname, and then we took that nickname and used it in the other equation. Then the third thing we did is we solved it. All right, and once you got your first variable all by itself, you got your answer, we did the fourth thing, which was plugged it back into the nickname. Right? Now, just remember, these are the steps for my particular technique. These aren't necessarily you're going to see in a textbook. It'll just say substitution, this and that, but the nickname is the same idea. So once you plugged your solution into the nickname, and that piece was when we took our nickname here, and we plugged our solution back into our nickname, you got your second variable, and you were done. Plug solution into nickname, and get second variable.